So welcome back. So let's start with a very simple question. When you send a message on the WhatsApp, how does it appear instantly on your friend's phone? My question is that when you send a message on WhatsApp, how does it appear instantly on the your friend's phone? Because something interesting is happening. If you think deeply, your friend's phone did not ask for that message at that exact moment. Okay, so you are sending the message, so at the same time your friend's phone is not going to ask, hey, what is, if you have some message, give me. So there was no request like, hey server, do you have any new message? No. But still the message arrived on time. That means server is pushing the update. Means earlier we are thinking this friend's phone, okay, and this is your phone. So friend's phone is asking, oh hey server, or hey no sender, do you have any message for me? So nothing. I mean, in between there is a server, you can consider it like that. So this is not going to ask any request. It's server responsibility now. It is sending the message. That's why message is arrived on time, in real time. So, and this is the core idea behind the real time sync or real time update. Now let's formalize this problem. So in traditional system, communication is always initiated by the client. Okay. In older version of application, if you remember or you have seen or worked, you might be knowing that in older system, communication is always initiated by the client using the HTTP or HTTPS call. Client send request, server respond, and connection close. So one request came, okay, server respond, and then close, connection close. Okay, this was the older flow. But in real-time system, this model breaks now, because here server needs the ability to send the updates whenever something happens, and that's where challenges begin. So before jumping into the solution, let's understand why our existing models fail, the older models fail or traditional models fails. Okay, so I told you it was HTTP call was there, right? So let's take a step back and understand how the web normally works. So whenever you open the website, your browser sent a request like, give me the home page, something like that, okay, the dashboard or home page. So give me the home page, and server respond with some HTML. Server returns some HTML code, right? And connection is closed, just like this one. That's it. No? So now imagine using this model for a chat application, what will happen? That is okay in this place. But suppose the same model we're going to in the chat system, what will happen? Your phone needs to keep asking, do I have any new message? Do I have any new message? Can you send me the new message? So this is going to be in a continuous polling. So this is called polling actually. So I keep on polling. I mean, my client is keep on polling to the server. Do you have any message for me? So at the first glance it seems simple, but now think at scale. So now let's say you are having 1 million users, and each polling each users are polling every 2 seconds. So polling request duration is suppose 2 seconds. Now imagine that's mean 5 lakhs request per second is coming per second, and all of these even when nothing is happening, I mean there is no message, no new message updates happen, but still this call is going on. So this is just wasteful, right? And not just that there is also a latency. If polling interval is suppose 5 seconds, a message can be delayed up to 5 seconds. So it's all depend on the polling interval. Because if I are given 2 seconds, it means every 2 seconds we are going to get some response. If I increase to 5 seconds, then what will happen? Now response between the two consecutive call is going to be 5 seconds, right? So we have two major problem here. First is too many unnecessary requests is going on, and second is delayed updates. So clearly traditional request response model is not enough. Okay, we are going to reject this. So now the question becomes, can we reduce this unnecessary request or still get the faster updates? So we are going to answer this question. Reduce unnecessary updates and faster update. It's a request, sorry, and this is the faster updates. Right, this question we are going to answer. So let's talk about the improvements, how the improvements happen. Okay, so we are going to make our polling little bit smarter now. Smarter here in the sense we are going to talk about long polling concept. Okay, so let's improve our idea of polling. So instead of asking again and again, what if the client asks once and server wait until something happens? So once I place the request to the server will not going to respond immediately. It will wait. It will wait for some time, suppose, and see if any message is coming or not. If any message is coming, it will return the result. Okay, so let's understand this again. So what is happening? One client is here. Client is going to place one request, like, do you have any message? This request reaches the server, and server will wait. It's keep on waiting, right? And one new message and new events arrived. Let me write new events arrived. Then it's going to return the result to the client. Okay, so let me draw it like that. So once it is coming, then it's going back to the response point. It's going back to the client again. Okay, so here from the server side, what will happen? Server will return the response object. This part is coming as a response now, and client will receive this. Okay, again client will send again one new request after that delay. Suppose 2 second delay we are considering. So after 2 seconds, it again going to place the request. Again it going to reach the server, and server will keeps waiting for some time. Okay, then again response will come. Then it will be encapsulated with the response object, and it will send back, right? So these processes keep going on. So here what is happening? Client sends request, but instead of responding immediately, server hold the request open. So wait means your request is not closed, request is open. Remember this. And it's wait, and only when new data arrive, it respond. Then the client send the next request. This is called long polling. So if we compare this with the simple polling, the earlier many useless requests was coming, now only when needed. So this is definitely better, right? But is it perfect? No, it's not really the close to the perfect. Okay, let's say two messages arrive quickly. Let's take one example. Two message M1 and M2 arrive at almost same time quickly. First message, server respond immediately. Okay, server respond immediately. But second message, client has not sent the next request. Okay, so on the server, suppose someone is sending message, two messages came at the same time, and M1 request is coming and first request is coming. So what will happen? Server respond immediately, right? For the first message, it's going to be server. I'm going to the client. But second message, client has not placed any new request. So second message is getting delayed. Though it is coming on the same time, but due to, we know that once the request is coming and once the first data arrive, that goes in the response. But the second message, it is still waiting for that polling request. So second message is getting delayed. Also, each update still require new HTTP request. So it's a very important point. Each request that I'm going to place is nothing but one HTTP connection or new HTTP connection. So first connection get created, then execution happened, then connection got closed in the last. So every time this I'm going to create and close for each message. Okay. So this is connection overhead. So you know that connection is a very critical and a very costly affair in any application. So we always need to do in a controlled way. So to improve things, so I mean things are improved. We know that unnecessary calls are reduced. Okay, but there is a connection overhead. So improve the things, but we are still don't have the true real time. Okay, because this message got delayed by 2 seconds or 3 seconds like that, because I mean based on the polling request buffer. Suppose 2 seconds it is there, then after 2 seconds this message will live, though the message was immediately available at the server, right? So now let's take one stronger question. Can we avoid the reconnecting again? Because this is what we are going to do for each request, right? So can we avoid the reconnecting again and again? Okay, we have to avoid the reconnecting. It is possible or not? Okay, so then another concept came, that is SSC concept. Is keep connection open. Okay, in this connection is open, and we call it server side events. Right? So instead of closing the connection after response, we keep it open, and server keeps sending updates continuously. Let's see this how. So client is here. Client is opening the connection. Okay. Server will send some data. Respond. Again send some data. Again send some data. Okay, and it's a continuous system is going on. So once the connection open, we are waiting, we are sending the data whenever arriving, but we are not closing the connection. Okay, so this is called server sent events. Now think carefully. Clients makes only one request, and server keeps sending updates whenever something happens, right? No reconnect, no repeated request. This is much more efficient way, but there is one limitation in that. What is that? Communication is only one way. This is only one way. We are not, suppose one more chat, one more user is there doing the chat. So this is one way. So I have to do the same thing from this way. Okay. So right now it is one way, and it is nothing but server to client. So client cannot send data on the same connections. So I cannot respond on the same connection, right? So if client wants to send something, they still need a separate HTTP request. If your friend wants to send some chat, he has to make another connection. Though that will also be a SSC connection. So, but still you require one separate HTTP request connection. So SSC is good for notification. So SSC is not for the two-way communication. Remember that. So whenever anything coming where you want to send the notification, sending the notification is always a one way. So when you want to send notification or some live dashboard, means some event is coming, we're just showing those things on the dashboard, like stock updates, because you just have to visualize the pricing. We're not going to send in your price, right? But not for chat. But for chat, this is not okay, right? So now one more final question. Can you have the full two-way communication? Is there any way? Now I want full two-way communication. Is there any way to do that? We call it duplex connection or duplex communication. And yes, we are having one very important concept for that, technology or methodology, WebSocket. You might have heard of this. WebSocket connections. So this is where WebSockets comes in. So instead of thinking in terms of request and response, we are going to now think in terms of connections. So let's understand this. How? We are going to think in terms of now connection. Forget about request, forget about response thing. Okay. So let's see the how it is going to do that. So initially connection start as HTTP, right? Client sent one request, HTTP request. Okay. Then this request get upgraded to WebSocket. The same request get upgraded to WebSocket, and once it is upgraded to WebSocket, now both client and server can send message anytime. So now here is the client, and this is a two-way communication and server. So it's a persistent connection. This is called persistent connection. Alright. So no request response cycle is there, just a continuous channel. So this is exactly like a phone call. When the call is connected, both sides can speak anytime. And this is the why region WebSockets are used in chat application. Okay, that's why this two-way communication it handles. So that's why I'm going to use this in a chat applications, and even in the gaming also, because there are multiple players who are sending the data. You have to see, you have to talk to them, right? Third one is the collaborating editing, like Google Docs. You are updating, some other person also updating in the same file. So this is called collaborative editing. Okay. So this, we got the solution. Okay, two-way communication is possible, but this power comes with some complexity. Okay, so this WebSocket connection having some complexity. Okay, it's a kind of proportional way, right? So first problem is that connection is persistent. Connection is persistent, right? What does it mean? So if any connection is persistent, it means server must remember which user is connected and which connection belongs to whom. Okay, which user, let me write one short form, which user connected and which connection belongs to whom. Okay, because you cannot I mean, this problem comes in when we are having the scale. This is going to cause one issue. Okay, but we will see that. So here you cannot randomly send request to any server because connection live on a specific server, right? And third point is that what if one server crashes? Server crashed. What will happen now? All connections are lost. Client must reconnect. So WebSockets are powerful, but they introduce complexity as well. This is what I want to show you. So now we have understood all the major way to send updates from server to client, right? So So let's summarize in this video what you have seen so far. So we started with polling, then improved it step by step. So like from polling to long polling, then we come to SSC, server side event, then we move to WebSocket. Okay. So each step solved, one problem. Polling solved simple but wasteful, request was going. Long polling reduced the request, and SSC is a continuous stream, but the problem was with one way. And WebSocket, full duplex communication, both way communication, duplex communication. But in any interview, someone is asking, you should not never jump directly to the WebSocket. Always evolve step by step. Maybe that problem is going to be solved by only SSC. It all depends on the context and situation. Okay, so this shows like, yeah, you are having the knowledge for each concept, like where to use. Okay, so far we solved only half of the problem. We figured it out how server sent update to the client, but still haven't answered how does server even know something changed. How do updates come from? How do they reach to the correct server? So that is a second hop, and we are going to talk about that. So let's talk about those problems that those complexity that is introduced by the WebSocket. Okay, let's see you in the next lecture.